Alright, my dear children of class 11 science, let's continue again with the topic that I was explaining in the last YouTube video. Actually, the topic that I was explaining is water with the glass surface, but mercury does not. Yes, this is a common experience that we see in our day-to-day life. When we put some water in a glass surface, we see that water stick with the wall of the glass surface, whereas mercury does not stick with the wall of glass surface. Okay, now what is the reason behind it? Is also due to the effect of what force? Cohesive, and what forces? Adhesive forces. Okay, now the adhesive force between the water molecules and the glass molecules is basically greater than the cohesive force between the water molecules. Okay, so when water is placed in a what? Glass surface. Suppose you have placed water. Suppose this is a glass surface, and if you drop some water, out here, okay, so this is water you have dropped on a glass surface. This is glass plate. Okay, so glass plate is made up of molecules, and water is also made of molecules. Okay, so easily what happened? The water molecules which is in contact with the glass plate, glass molecules, they are the glass molecules also. Now what force which exists between the water molecules and glass molecules? Adhesive force. Now this adhesive force between the water molecules and glass molecules will be greater than, so in this case what happened? Adhesive force will be greater than what force? Cohesive force. Cohesive what? Force. So cohesive force exists between the water molecules also. Now when the cohesive force exists between only water molecules, whereas adhesive force exists between the water molecules and glass molecules, but this adhesive force will be more than the what force? Cohesive force. So in this case what happened? When water is simply poured on the glass, okay, water is simply poured in the glass, we see that water simply weight the glass. Well, weight the glass means it will stick with the wall of the glass because of more attractive adhesive force than the less attractive what force? Cohesive force. Okay, that's why what happened? Water will simply weight the what? Glass. But on the other hand, if mercury is simply poured on the glass plate, okay, on the what plate? Glass plate, the forces exert between the molecules of mercury and the glass, and this force, as you know, is called what force? Adhesive force. And this adhesive force between the molecules of mercury and the glass will be less than the what force? The cohesive force between the molecules of mercury. So under this case, okay, the molecules of mercury will not stick with the wall of glass because of less adhesive force. In this case, the adhesive force between the molecules of mercury and the glass will be less than the cohesive force between the molecules of mercury. Between the what molecules? Cohesive force between the molecules of mercury. So due to more cohesive force and less adhesive force, that mercury will not stick or does not weight the what? Glass. But one case that can be observed in this part is that if the glass surface is greasy, if the grease is put on the glass, in that case, if you pour some water on the greasy glass, then what happens? That water will also does not stick or does not weight the glass. Now why? When the greasy surface is placed on the glass surface, okay, then when water is poured on that glass, okay, in that case what happens? The adhesive force between the water and the grease will be less than the cohesive force between the molecules of water. So in that case what happens? The water will not stick with the what? Glass. Okay. So children, one of the most important effect that you can see of cohesive and adhesive force is the way water with the glass. But whatever water, pure water with the pure glass, I mean with the glass without any impurities and any grease surface, whereas mercury does not with the what? Glass, or does not stick with the what? Glass. Now children, we go to the next topic, as I explained with the simple example that the effect of cohesive and adhesive forces. Now the next topic that we had to memorize and we have to learn is that the factors affecting surface tension. See, surface tension, as you learn, as one of the property of the liquid, by virtue of which the liquid behaves like a what? Elastic membrane, stress membrane. Okay, and this surface tension can be observed in a liquid. Okay, and due to this surface tension, we saw that the formation of soap bubbles, okay, and formation of what? Water droplet. Okay, it is all due to surface tension, and even the surface tension makes a small drop of what? Mercury form a what? Spherical shape, that is also due to surface tension. Okay, and due to surface tension only you saw that small needle placed on the water. Okay, that needle simply pulled on the water. That means there are a number of example and the effect that you saw in due to surface tension. But surface tension of a liquid can change due to some of the factors. Okay, now let's discuss in detail about the factors affecting surface tension. And children, we basically learn 4 factors that affect surface tension. Okay, so let's discuss one by one. So one of the first factor, let me just discuss, is the effect of temperature. Means temperature is one of the factors that changes the surface tension. But how it changes, that part we are going to discuss. Okay, basically the surface tension, let me just write down the surface tension of a liquid. Of what? Liquid. Basically the surface tension of the liquid decreases. Surface tension of the liquid what? Decreases with increase. Decreases with what? Increase in temperature. Increase in what? Temperature of the liquid. So for any liquid, if the temperature of the liquid increases, the surface tension decreases. Surface tension what? Decreases. Like if I take water at 0 degrees Celsius, it has a maximum surface tension. But when the temperature of water increases from 0 degrees Celsius to more temperature, then in that case what happens? Surface tension of water decreases. Okay. Now this surface tension of liquid becomes 0 also at critical temperature, and becomes what? Become 0 at critical temperature. Now this critical temperature is the maximum temperature in which the surface tension can be reduced to what? 0. Then after that, okay, that means the liquid does not acquire any surface tension at all. Okay, but this critical temperature is not same for all the liquid. Now number 2 factor that also affect the surface tension is surface tension also affect the presence of impurities. Yes. So children, the presence of impurities also changes the what? Surface tension. But depend upon what type of impurities that you are adding to the liquid, because some impurities are highly soluble and some liquid are insoluble in what? Liquid. Okay, that's why the surface tension changes accordingly. It decreases or it may what? Increases. But presence of impurity changes the what tension? Surface tension. Now I just want to add surface tension changes. Surface tension is what? Affected. Let me just add on. Surface tension is affected by the what? By the presence of what? Impurities. By the presence of impurities. Okay. So I take the impurities, 2 types of impurities. One is soluble and another is insoluble. Now suppose if the impurity is what? I'm writing out here. If the impurity is highly what? Soluble. Highly what? Soluble. Let me just take one example out here. So the example is sodium chloride. You know sodium chloride is a salt. Now if I add sodium chloride in water, so sodium chloride as an impurity, if I add in water, and you know sodium chloride will soluble in water. Okay. Then what happened? The surface tension of that liquid, like water, increases. So in this case what happened? The surface tension of liquid, like we are taking what? Liquid, just like here, water, increases. So to say in a simple way that surface tension of that liquid increases when you add impurity which is highly soluble in that liquid. If you add some impurity in that liquid which is highly soluble in that liquid, the surface tension of that liquid will increases. Okay. Now this is the first part. But there are the certain impurities which are insoluble, which are partly soluble in liquid. Like I'll take if the impurity is okay insoluble, or I can use the word partly soluble in water, partly soluble in liquid, not only water, sorry, partly soluble in liquid. Okay, like example, I give you one example out here. Like I take phenol. The phenol is insoluble in what? Water. Phenol is insoluble in water. So in that case what happens? The surface tension of that liquid like water decreases. In that case what happens? The surface tension, okay, the surface tension of liquid, like I am taking the case of liquid like water, decreases. So when surface tension of liquid decreases, when we add some impurities on that liquid which is insoluble in it, means that impurity which is insoluble in that liquid, so that the surface tension of the liquid what decreases. So in order to decrease the surface tension of liquid, we need to add the impurity which is insoluble in the liquid. So this is number 2 factors that affect the what? Surface tension. Now we have 2 more factors that also affect the what? Surface tension. And the number 3 factor is the surface tension of a liquid also depend upon the medium presence on the other side of the liquid. So the presence of medium means, I write down, the presence of what? Medium present on what? Present on the what? On the other side. Medium presence on the other side of the liquid also changes the what? Surface tension. So the surface tension of the liquid also depend upon the presence of medium. Okay, depend upon the medium present on the other side of the what? Liquid. So this is also the factors that affect the what? Surface tension. Now we have a last factor to discuss. The surface tension also depends upon the nature of the liquid. Also depend upon nature of the liquid, less, because the liquid is, all the liquid are not of same nature. Okay, so depend upon the nature of the liquid, the surface tension depends also on the nature of the liquid and is also independent on the area of free surface of liquid. Means whatever amount of liquid you take, okay, and whatever area the free surface of liquid occurs, but the surface tension depend upon the nature of the liquid. Depend upon nature of the liquid, but as I said, it's independent on the area of the free surface of the liquid. So children, the last factor which I had already explained, that factor only I have written out here, means surface tension depends upon the nature of the liquid but independent on the area of free surface of the liquid. Okay, so these are the 4 important factors that affect the surface tension of the liquid. Okay, now we do this much today and we do continue next class with other topic from this chapter. Thank you so much.